Today in this video, we're going to be covering chapter 3.5.1, which is factoring polynomials, and the GCF, which is greatest common factor and grouping. Now, this one is, we're getting into some of the more heavier stuff to learn about, and the stuff that is going to be more important and used a lot in your future math classes. So, I'm going to try to be thorough and explaining well. So, to start with is the greatest common factor. Well, first we're even going before then. We're doing prime factorization. It wants us to make sure that we know everything up to the point until we start learning about the greatest common, the grouping by polynomials, because all of this will be relevant to that. So what we can do is we want to find the prime factorization of some numbers here. Now, if you remember, prime factorization is when you have like a number, say 8, and you want to split it down as far as it can go. 2 is a prime number, so you can't go any farther than that. So, for instance, it says, here's 300. And if you're lost when you're doing these, the easiest thing to do is, if it's an even number, just divide by 2. However, I know that 30 and 10 go into 300, and I'm going to use those because they're large, and it will be easier to deal with. So, we'll do 30 and 10. 10 and 3 go into 30, and then 2 and 5 go into 10, and then another 2 and 5 go here. So 3 is a prime number, 2 is a prime number, and 5 is a prime number. However, so it's 3 times 2 times 5 times 2 times 5. So we have two 2's, so we'll do 2 squared. We have times a 3, and we have times a 5 squared. We have two 5's. And that would be your prime factorization of this 300. Now we have 198. For this one, I'm going to do the dividing by 2. That's going to be the easiest for me. And we'll just do this really quick. So I'm going to divide by 2. 198 divided by 2 is going to be, here's 9, 18, 1, 18, 99. So we have 99 and 2. I know that 99 is 9 and 11. 11 is a prime number, 2 is a prime number, 9 can be split into 3 and 3, and 3 and 3 is a prime number. So we have 3 squared times 11 times 2. And then for 240, we are doing the exact same thing. So we have 240. I'm going to divide by 10 because I know that there's a 0 at the end. So I have 10 and 24. 10 is 5 and 2. 24 is 12 and 2. 12 is 6 and 2. 6 is 2 and 3. So we have 4 2's. So 2 to the 4th. And then we have a 3 and we have a 5. These would be your answer for that. This is important because when we are doing factoring by grouping, as well as factoring through by trial and error and the AC method, basically a lot of the stuff that we're doing in this class will be involving factoring and prime factoring, finding the greatest common factor. This is the same idea. We're going to find 6x to the 4th, the prime factors of this. We know that 6 can be 2 and 3, and we know that x to the 4th is just 4 x's multiplied together. However, yeah, so it'd be, it may just be 2 times 3 times x to the 4th. I don't remember how Lumen wants it. Give me just a moment to look at it. Okay, yeah. It does want it in like x to the 4th. Now this one we have 35, x to the 3rd. We're just keeping the x still. So we have 7 and 5, and those are both prime. So 7 times 5 times x to the 3rd. And then 40 is going to be 4 and 10, which is going to be 2 and 2 and 2 and 5. So 2 third times 5 times x squared. Now this is a little bit, we're taking the same idea, but we're broadening it to 2 different terms. So now we have 14x squared, and we have 21x to the 4th. And ways that we can do that, we can say this is x squared, and this can be brought down into x squared and x squared. We're just trying to see if there are any common things. And then 14 can be 2 and 7. 21 can be 3 and 7. And these both have an x squared in common. So they both have an x squared in common, and they both have a 7 in common. So we have 7x squared, and that is going to be your greatest common factor. And the way that would be represented, so this is the answer that it's looking for, just 7x squared. But if we were going further, and we were saying, okay, this is 14x squared, and say plus 21x to the fourth, and we wanted to find the greatest common factor, we would take that 7x squared out, and we would say, what happens if I divide 14x by 7x squared? And that would give you 2, just 2. And then what would happen if I divided 21x to the fourth by 7x squared? And that would give you positive 3x squared. And that's what your new form would look like. And if you multiply it back out, it should give you what you originally started with. So we have 7x squared times 2. That's going to give us 14x squared. And we have 7x squared times 3x squared, which is going to give us 21x to the fourth, which is exactly what we started with. Now we're talking about 3. So we have 35x squared and 30x to the fourth and 15x cubed. So these have an x squared. This has 2x squareds. This has an x squared and an x. I didn't give myself enough room here. 1 second. So we'll spread them out a little. And this has a 7 and a 5. This has a 6 and a 5, which is a 2 and a 3 and a 5. And this has a 3 and a 5. So they each have a 5, sorry. And they each have an x squared. So we're going to take out a 5x squared. So we have 5x squared. That was your greatest common factor. Now this one looks really intimidating, but they're just trying to scare you. It's easiest if you do basically what we've been doing before by writing out each of the terms. 133 f to the 39, t to the 25, and then 14 f to the 24, t to the 38, and then f to the 91, and f to the 26, and t to the 37. Now, 133, I don't know off the top of my head if that is prime or not. I'm going to test some numbers. So I'm doing 133 divided by 2. I know that's not going to work because it's not even. Divided by 3, it gives me a decimal. I only want integers. And it looks like 7 and 19. So 7 and 19. I just went from 1, 2, 3, 4, 5, 6, 7. And then it gave me something that was not a decimal. And then before I start spreading these out, I'm going to say, okay, what's my degree, my f to the lowest degree? And it's going to be this 24. So we can take out an f to the 24. And we can take out an f to the 24 here. But that leaves us with the remainder of the rest of it. So 39 minus 24. Because if you remember, division of exponents is basically subtraction. Well, not like basically, but we can figure out what it is by subtracting. So we have 15, so f to the 15. And then same for the t. Our t of the lowest term is 25 here. So we'll do t to the 25, and we can take out a t to the 25 here. But we can also, that leaves us with the 38 minus 25, which is 13. So t to the 13. And then we have a t to the 25 here. No, sorry, an f of the 25, because I forgot that we want actually f of the 24 here. And then also f of the 2, because that's our leftover. And then we also have t to the 25, because we want t to the 25 for this one, since that's our lowest degree. And then we also have t to the 12. And then we have for 14, 7 goes into 14. Now, I'm sensing a pattern here. We have a 7 and a 7 here. I'm assuming that 91 is divisible by 7. And let's hope. Yeah, okay, so it's 7 and 13. 7 and 2 here. So they all have a 7 in common. They all have a t to the 24 in common. F to the 24 in common. And they all have a t to the 25 in common. over here. So our greatest common factor would be 7, f to the 24th, t to the 25th. That would be our greatest common factor. Hopefully what I did there made sense. I know I was kind of going through it quickly and not explaining each of my actions, but basically I just wanted to see what they had in common. And I wanted to manipulate it in a way that I would be able to figure that out, see what they have in common as well. So now the next one is more simple. It says factor out the GCF. Now, this is almost exactly the same. However, this time it's not separated by commas or ands. It's separated by subtraction. In some cases, addition. Now we want to say, what can we take out of here? What can we divide out of here? And both terms, 4 goes into both terms. So 4, if we take out a 4, we're left with a 1t, because 4 divided by 4t is 1t. And then if we divide negative 12 by 4, we are left with a negative 3. So we have 4 times t minus 3. And so it wants our GCF to be 4 here, because that's our GCF. And then it wants the t minus 3, and it already has parentheses in that one. It's saying, what is our new equation, basically. And it has the same value. It's not changed. If you multiplied this out, you would get the same thing, the same value. However, we just changed its appearance. And that's sort of where this is going with the grouping. We're just changing its appearance and making it into a new form that is easier for us to work with. Now it's saying factor out the GCF out of each term here. So we have 48x to the 5th minus 8x to the 4th and 32 plus 32x to the 3rd. Now it's still helpful to be factoring stuff out. So I know that 48 is 6 and 8. Let me double check. I'm so bad on my times tables. Yeah, 6 and 8, which is 2, 2 and 2. And 2 and 3. And then 8 is going to be 2, 2, and 2. And then 32 is going to be 8 and 4, which is 2, 2, 2, 2, 2. So there's a lot of 2's that we're dealing with. Luckily, we only need to worry about the least amount. So there's 3 2's here, 3 2's here, 3 2's here. And we want to make sure we are still keeping track of what's left, because that's going to be important for these problems. And also, our lowest term here of our x is a cubed. So we can take out a 2 to the 3rd, but we want to simplify that to 8x to the 3rd. So that's our GCF. And then what happens when we divide 48x to the 3rd by 8x? That's going to give you 6x squared. What happens if you divide 8x cubed by negative 8x to the 4th? That's going to give you negative 1x, or just negative x. And then what happens when you divide 32x cubed by 8x cubed? That will give you positive 4. So this is your answer for this question. We're basically just dividing. This is why we were working on some of the dividing of a polynomial previously, because we're basically just dividing here. That's all we need to worry about. It's just presented to you in a different fashion and in different language. But we've done this already. Yeah. And then, yes. It also gives us this helpful hint that if the leading term is negative, the GCF is negative. And that's an important thing to remember. When we're factoring out the GCF of something, when we're going to factor the polynomial, we want the leading term, which is the term that has the highest degree, to be positive. That's something to keep in mind. Now, without further ado, we're now going to be talking about factoring, specifically factoring by grouping. When we're talking about factoring by grouping, we're saying we basically want to take out like GCFs of stuff. It's like we want to make it simplified. We want to manipulate this equation to make it easier for us to do certain things with it. Factored forms are really useful for finding when x equals 0, which is basically like solving an equation. We want to see where the x-intercepts are. Now, to begin, it's usually going to be convenient for you. When we're talking about factoring by grouping, what we do is typically there's going to be 4 terms. 4 terms in this unit. and in this class, you'll see 4 terms when we're talking about factoring by grouping. So you'll put little parentheses around them, and you'll separate them. So you'll say, okay, what can I take out of x squared plus 9? What can I factor out of here? And it looks like nothing. Well, actually, sorry, it's 9x. It looks like we can take an x out. So we have x plus 9 now. And this one, we can take out a 10. So we have a 10, and we have an x plus 9. Now the crucial part for when you're doing factoring by grouping, using the AC method or trial by error, the crucial part is when you're at a step like this, the insides of these 2 parentheses have to be the same. And so we have our x plus 9, and we want to also take this x here and this 10, and we'll do x plus 10. Because this is a positive 10. Essentially what we're doing is we're basically just dividing this whole statement by x plus 9. And we took it out. We took out another greatest common factor. The greatest common factor of this statement is x plus 9, leaving us with x plus 10. However, basically, you don't need to necessarily know that. It's just good to know that it's just good to know, you need to know that we're taking the x plus 10, and then we're keeping whatever is in those 2 parentheses that are the same. That's very important. So this is our factored by grouping form. Here's another example. We have 3x squared y plus 5xy plus 21x plus 35. Again, we're going to separate these 2. We have 3x squared y plus 5xy. It looks like we can take out an x and a y. 3 does not go into 5 does not go into 3, so we're left with the 3x plus 5. And then we want this statement to be the same as well. These are both divisible by 7, so we'll take out a 7, and that will give us, and this is a plus 7, positive 7. We'll get 3x plus 5. And now we have one of our parentheses, which is 3x plus 5, and we have xy plus 7, and that would be your factored by grouping. Yes, that would be your answer right there. If you have any questions, please let me know. I know this is a lot to cover, and but if you have any, just let me know. Shoot me a text. Have a good one.